Okay, this is the video solution for problem number 3 of the midterm given to section 52. As you can see, this is an assembly problem. It's an assembly of two solid parts, okay? An aluminum part and a steel part. When these are shrink fitted and you're asked to use the most appropriate element, obviously the most appropriate element is the solid elements, okay? The tetrahedral elements. And uh, you must have local mesh refinement on at the interface, and you're asked to use as many planes of symmetry as possible. Obviously, if you take that disk and cut it into two pieces, you're going to have the top and the bottom. That's a plane of symmetry. And then you can take a 90-degree sector here, but a very special 90-degree sector. You can take the vertical cut and a horizontal cut. You get a 90-degree sector here, which obviously has these two half circles in it. Or you can take a 90-degree sector like that, which means this circle is going to stay intact as a circle, but then it's going to look like that, like the slice of pizza on the top. Okay, I'm going to do the first one. Most likely, it's most likely that you're going to take a vertical and a horizontal cut. Okay, so that's how I'm going to do that. So let me go ahead and start a product file. So there is my product file. Okay, immediately save it. File, save management, save as. On the desktop, new folder, and I'm going to call it a midterm. It's lab 52, and it's an assembly problem. Assembly. Okay, so everything is going to go there. So we're going to insert the steel part. Let's do the steel part first. Insert a new part in there. Right click properties. I'm going to call this thing steel ring. Steel ring and steel ring. And let's make it. Double click on it. On this horizontal plane, I will sketch. Remember the 90-degree sector, so we're going to do it like this. Okay, and then I have uh, a ring like this. Let's clean it up. So from here to there, and from here to there. Okay, this outside radius is 5. The inside radius is 3. Diameter 6, obviously. Okay, and we have two circles here, which is 4 inches away. So let's draw a half a circle there. Okay, and another one up here. Oh, sorry again. Somewhere down here. We're going to dimension it in just a minute. Okay. Now, first of all, the distance from the center of this to the center of the coordinate system, you're told, uh, let's try it again. The distance from this center to, okay, no problem. Just select the distance from the center to the x-axis. How about that? Oh, something is, okay, I think there is a problem here. Let me see for a second. What did I do here? Let's try this one. Let's try that one. That center to this. Okay, so it looks to me that there is a constraint here. See this? Is that in the middle by any chance? I didn't intend it to be in the middle. Let's see for a second. No, constraints. Uh, yeah, somehow it ended up in the middle, which let's actually, that's fine. Let's measure the distance from here to there. If it's 4, we don't have to dimension it. What does it say? 4. Okay, so when I created that circle, I didn't intend it to be. Somehow it put the center right at the origin. No problem. Okay, that's good. That's good. Uh, don't worry about it. Okay. So let's see now. We have this dimension of that circle. The radius is zero point 0.5. Let me see what the radius is. It says the radius, not there. The radius is 0.25. The radius is 0.25. Okay. So let's go here. This should be radius is 0.25. Okay. And this radius is also 0.25. 0.25. Okay, and let's clean up. Another, we have to get rid of this horizontal piece. Quick trim. Oops. Okay, there we are. That's fine. This has to do with that uh, center point, being automatically picked. But don't worry about it. It did it. Okay. See, it says the middle point constraint might be modified even when deleted after. Okay, fine. No, we understand. Okay, very good. This is the thing that we have. And we're going to exit. Okay, let me close this. I don't want this junk. And then pad it by half the height. Half the height, the whole height is 1. We pad it by 0.5. You say okay. And this is made out of steel. Okay, apply material, metal, steel on this part, not on the assembly. And there we are. Let's save this. And now we're going to insert. We're going to insert our aluminum part. Now, to save it, I'll go to the top level. Top level here is easier. And just click on the floppy. It's going to put it in the same folder. Now we're going to insert the new part. Say no. And this is going to be the aluminum ring. Properties. Aluminum. Or aluminium. Aluminum. Good. Okay. Now let's make it. Double click on a convenient plane on that same horizontal plane. We do exactly the same thing. So we're going to make 2 rings. One like that. Another one like so. Close it up. And close this up. Did I close it? Yeah, it looks like it. Okay, now this dimension. This outside one is slightly bigger than this, so it says that it's 3.001. Okay, and if you zoom in, you see that it's a little bit to the right of it. You can see that. Okay, good. And this the inside one is radius of, I believe, 0.5. I think so. Yep, diameter. Yep. Okay, good. So we exit, pad it by half the height, and that is 0.5. 0.5. Okay, let's actually change the color of that. I'd like to change that color. Uh, Properties on the graphics, yellow. Okay, very good. And we're going to make this thing out of aluminum. So apply material on this part, aluminum, and say okay. And we're going to save everything. Go to the top level, and then floppy. All right. Now we're going to go to generative structure analysis, get these two solid parts. Immediately it meshes both, which is fine. We're going to keep the sizes the same. And let me see, let me change the rendering here, by the way. Okay. You are asked to may have a local mesh refinement about the interface. Okay. So what we're going to do is we're going to go to the second toolbar on the left, this guy. Local mesh size. Remember, it waits for you to pick which one. So let's do the steel ring first, and I'm gonna hide this guy. Select the inside of the steel ring. I put something like that, zero point 0.1, fine. I have no problem with it. And then again, this time the aluminum, and it says where. So aluminum part is hiding. So what we want is that part. Again, same size. Let's bring this thing in the front. And it did both of them. It's just that you may not be able to see both, but if I change it to wireframe rendering, you can see that these are it. One on the steel side, the other one on the aluminum side. Excellent. So change the rendering here. Very good. Let's save the analysis file, say management. This is the analysis. Save as in the same folder, which is Medium Lab 52. Assembly, default name analysis. You're going to say OK, and let's move on. Okay, so first of all, surface slider. This is a plane of symmetry. That's a plane of symmetry, and so is this. This is a plane of symmetry. That's a plane of symmetry, and this is a plane of symmetry. And so are the bottoms. Don't forget the bottoms. Okay, very good. Now we have to create a connection between the surface of the surface of the steel and the surface of the aluminum. So for the first component, let me hide the aluminum, surface of the steel. For the second component, let me select the surface of the aluminum on the side. Say okay, let's bring it in the front. Okay, so there is that connection that was just created. And we have done problems like this, so you have to do a shrink fit, okay? So pressure fit or shrink fit right there, right there. See that? Right there. Face-to-face connection, you click on it. It says, where is the support? The support is that connection that we just created, which is, you can do it from the G or this white dot here, either one. Either way, it doesn't matter. And the radial interference is 0.001, because remember, the radius of the inside piece is 0.001 bigger than the radius of the outside. So that's what the overlap is. And we say, okay, and we're going to save everything. And we just run it. That is basically your load. There's nothing else. Okay. So let's run it. Excellent. No problems. So let's look at the deformation. You know, this is going to go out, this is going to come in, and therefore it looks like a big gap between them. We have done problem like that. And if you don't like to see this gap, no problem. Double click on it. Say, just show me the steel ring and the aluminum ring. Don't show me all this intermediate stuff, and don't scale up the gap. Where is that? Right here, right there. Automatic magnification. Just make it 1. If you want to see the real deformation, that's what it is. Scale of 1. That's what it is. And if you want to see the stresses, of course, things like that, same thing again. Change the rendering here. Don't show me all the junk. Don't show me all the junk. Just show me steel ring and the aluminum ring. And don't scale it up for me. Scale of 1. We don't expect you to do these on the test, but you can see that there's a sudden drop in the color, and that's because the materials are different. That is understandable. That's it. So hopefully you did it correctly.